So hopefully that doesn't disturb the speaker. But my name is Dennis Sylvester. I'm the Senior Associate Chair of ECE here, and I'm here to welcome you to today's talk by Rick Bergman. He was the recipient of the 2019 ECE Alumni Impact Award. So the Alumni Impact Award is the highest recognition granted by ECE to its alumni. It recognizes individuals who have made significant and lasting impact in their field. Rick has had a major leadership role in the computer graphics industry and is the new Executive Vice President for Computing and Graphics at Advanced Micro Devices, which you may know as AMD. It's a homecoming for him because he previously worked at AMD from 2006 to 2011, joining after AMD had acquired ATI Technologies, where he was a senior VP, and he had helped make the company attractive to AMD by growing their graphics market share from 17% to over 50% before the acquisition. So that was a big deal. And when he was at AMD originally, he managed a team of more than 5,000 engineers. So a massive effort, and launched the first generation of AMD Fusion processors, which combined graphics and CPUs. So he left AMD in 2011. He became president and CEO of Synaptics, which is a $2 billion company with capacitive touch technology, which is found in devices around the world. I think it's some of the Lenovo ThinkPads, maybe.
It's every notebook.
Yeah. So he's back at AMD now. He's going to make an even bigger impact on computing and human interface solutions. So maybe we'll hear some about that today. Rick graduated from Michigan in 1986. We were just discussing this building opened in 1986. So I don't know if he's seen this building. So it's new to him, but not new to us, unfortunately. So he got his undergrad degree in EE, and then went on to get his master's in business administration. He's worked at several other companies early in his career, but I think we should hear Rick speak. So I'm delighted to welcome Rick, our Alumni Impact Award winner, back to Michigan, and now to the podium. Thanks.
All right, thank you. Thank you, Dennis, and thank you for inviting me. It's kind of exciting coming back after all these years. I do come every year. It's just I come from homecoming, and it'll be one of my lessons learned at the university here. There's like 25 of us that show up every year, and we have events planned during that time frame. So what I was going to do is talk a little bit about kind of my career, do a little bit of commercial for Synaptics, my prior employer, and then a little bigger commercial about AMD. But really, it'll be a free-forming discussion and leave plenty of time for back and forth discussion if you have any questions and answers. So first, Dennis covered a lot of my background, but roughly 30 years in high tech, and it's been an exciting 30 years. Notice there's a lot of interns here, so I actually did my internships. I did 3 of them with IBM down in Boca Raton, Florida. So IBM used to have a site there. So as you well know, about this time of year, if you were in Boca Raton, Florida on the beach, it's a nice break from the academics here at Michigan. So that was great. And then I immediately went to Texas Instruments after that. And then kind of I did a startup thing for a little while, and I'll get into that in a second. And so what did I learn? So I kind of already hinted at the first one. So the friendships that you make sitting around this table last a lifetime. So as I said, I come back every year, and there's 20 or 25 of the people I went to school with. And last night, my hotel reservation got screwed up, and there was no place for me to stay. But fortunately, one of my former roommates from college still lives here in Ann Arbor, and he was able to help me out, and I'll be hanging out with him for most of the weekend. So think about that. And we didn't have all these fancy things like Facebook and Instagram and like that to keep in touch, but yet we still managed to do it. There's no substitute for hard work. I have 3 daughters in their 20s, and they often lamented as they go through the academic rigors about how tough it is. And they can't wait to be done with their degree. And I'm sure your parents have said, enjoy it. And so I will say the same thing, because there's the billionaires, the 0.01% that find a way to make a lot of money in their late 20s. But the reality is, people like me that manage thousands of engineers, there's the super smart ones, the ones that work really hard and the ones that are super smart and work really hard stand out. So don't think it's going to get easier. Understanding hardware and software. So I had a sister that was a computer science major that was 4 years older than me. And I remember when I was first starting at Michigan, she said, so she was obviously software, make sure you learn software along with hardware. And I did, so I took an abundance of software courses. But now that I'm in senior management, our most valuable employees are the ones that move smoothly between hardware and software discussions. They're very rare, but they understand the OS stacks and the machine learning pipelines, as well as, well, what does it mean from a hardware perspective? How can I eke out the most performance? The most important skill you learn is solving problems. So I obviously have taken on more of the business stack during my career, but invariably I have to deal with engineers on a day-to-day basis. I say that, I have to deal with engineers. There's probably a better way to say that. I get the pleasure of working with engineers every day, and they and we are always solving very complex, interrelated problems. And so, sometimes it feels academic. I admit some of the courses I've never had to use what I've learned here ever again. But what I did learn is how to solve tough problems. And then the most exciting thing is technology has incredible ability to change lives, and you'll see that multiple places in my presentation. So it's just super cool what we all get to work on and how it changes the day-to-day. And I'm sure hundreds of years from now, they will look back on this era and just say, what an amazing time of innovation that has occurred. And the great part is we get to be right in the middle of it. And just kind of 1985, so when I was here, so my saddest story of my age as I get to this part of my career, I don't want to give the old guy stories, but I actually used punch cards when I came to Michigan in my freshman year. You guys even know what punch cards are? Do you have the vaguest idea? I see a few heads nodding up and down, but it's this big stack of where you'd put your computer code on, and you run it through this machine that read off those cards. And one thing you would quickly learn is don't make the mistake between an L and a 1 or a 0 and an O. Because guess what you'd have to do is you have to pore through all those cards and then find the one that had the typo and replace it with a different card and have it run through the machine reader again. And that was Michigan. Michigan, that would have been 1980, 82, I guess. It's shortly thereafter, got a mainframe and life was much, much better. But they used to charge too. So I don't know if that's still the case, but when you used machine time, you would give an allowance of $50 a semester or something. And you could only use so much compute time a semester. And once you ran out, you were done. That was it. No more. So you had to be very efficient in your code and your approach. So we obviously have made a lot of progress during this time frame. And now, so this is a lot of the AMD stuff. So super cool processors and PlayStation 4s and really sleek machines. Last week, I happened to visit Magic Leap. I can't say a whole lot about it because it's confidential agreements. But they kind of have this vision, what they've talked publicly about, how all this stuff on this screen is going to be replaced. And the silliness of us all, like I was just doing, looking down at your phone and walking around and bumping into things. I am sure when you guys come back to Michigan 30 years from now, you'll put smartphones up on the screen, and the students will all laugh about it. And you'll tell stories of how your screen time was 6 hours a day, and that's all you would do is look at it. And so this is the kind of progression of my career. There's some people that work at one company continuously. I kind of had kind of 3 slices. I've been working 30 years, so about three decades. So my first decade was at Texas Instruments, and that would kind of be one thing. I know startups are the rage, but if you get the opportunity to go work for a company and get a really solid foundation where you can learn how to solve problems and learn how businesses operate and so on, like Texas Instrument was great for me because I was able to develop those skills, and I got my MBA at the same time. They sponsored it, and they just have a lot of natural training that occurs that smaller companies just don't have or can't afford to. But I got the startup bug, so I went to a startup called Exponential. And it was a grand and glorious startup in its day. And It was related to Apple, and I'll just kind of leave it at that. But we were going to IPO one month. The next month, we couldn't make payroll. So it was a learning experience. And so then I went into graphics, so a company called S3 Graphics for the first time. They're still around in some form or fashion, but that's the first time when I became a vice president of a public company. They were acquired, and when that happened, I moved on to ATI, yet another graphics company. That was in 2001, as Dennis mentioned. There I ran multiple businesses, and they were acquired by AMD. So you can kind of see a theme in technology. There's quite a bit of M&A. And I was at AMD then combined between ATI and AMD for 10 years. And then I had the opportunity to become a CEO of a public company. And so Synaptics, and I'll spend some time talking about that. I was a CEO for 8 years, and just a couple months ago, I returned back to AMD. So what is Synaptics? Probably no one in this room has heard of Synaptics, but probably everyone in this room uses Synaptics products every day. So, for example, so Synaptics is touch. So our vision was lead human interface. So wherever the human interfaces with the machine, we should be on the forefront of that. So on this lovely HP notebook, there's a touchpad. And so that touchpad is actually a Synaptics product. There's also a fingerprint reader off to the right. That is also a Synaptics product, because of course those are in human interface. Pretty much every iPhone till the last year or so ago used a Synaptics product, display driver, to actually drive the display. It's the visual interface as well. And so that was our vision. If our vision was basically to make the devices easier to use. Yeah, the company was established in 1986, and I'll tell a cool little story about it. Public company, as I mentioned, a little less than $2 billion of revenue. It's going through some changes right now, but around 2,000 employees. And so the cool little history of the company, is there such thing as engineering history now as part of your curriculum? No? You don't have to be forced to hear about the longtime inventors of this industry, but we had two very famous co-founders. One is Federico Faggin, but they're both still alive, by the way, where he's generally credited with inventing the microcontroller back in 1970 at Intel. And then the little more famous one is Carver Mead. And I actually used his textbooks, believe it or not, when I was in school. He's a professor, still is an emeritus professor at Caltech. He is actually the one that's credited with coming up with the term Moore's Law, just to give you an idea. But Synaptics was actually formed, and I actually want to read, just to show how smart some people are, the kind of their founding documents. But they were formed to commercialize analog neural network chips in 1986. And let me pull this out. In the documents that we found, it said their vision was to create chips that mimic the way the brain works in order to perform ultra-low power pattern matching suitable for use in vision and speech recognition. That was 1986. So to me, that was incredibly impressive that they had that vision, but sometimes you don't want to be too visionary. So we ended up with this really cool name. So again, the company was founded with this name Synaptics, which probably has a lot of value just in the name of the company compared to with what's going on with artificial intelligence and so on. But obviously, it was the connection of the neurons. And so the initial company's product was to read checks and verify that the signature was there and the other data, obviously doing some pattern recognition there. That didn't succeed commercially, so they switched and did trackpads or touchpads. This became the foundational part of the product. When I joined the company then in 2011, we expanded that vision to be broader than just touch. And so if you look back in the 2011, I kind of think starting in 2010, it was really a decade. This is a decade of human-machine interface, because up to then, it's really been kind of boring. Go back, way back to the keyboard, the QWERTY keyboard, so that everybody uses every day on your notebooks, was actually invented in 1868. So that unusual QWERTY, hence the name, pattern. So that predated Thomas Edison's invention of the light bulb by 10 years. And yet, here we are, 150 some odd years later, still using that same exact keyboard. And that was generally true. That's all we ever used up through kind of 2011. And even the initial smartphones would have the old Blackberries would have a mechanical little keyboard in that QWERTY format. And you guys are still using it as a touch basis. But touch really started to take off in 2010. iPhone generally, or Apple gets the credit for that, but actually Synaptics worked with LG and predated the iPhone by about 6 months with a touch interface. So we claim we were the first capacitive touch company in the world. So that's suddenly, so now human interface expanded to not just keyboard entry, but touch. And about 5 years ago, kind of our statement was, well, your first interaction with any smart device was through Synaptics. So whether you were touching your phone or touching the touchpad or the fingerprint reader, you were coming through Synaptics first. But then something happened 5 years ago, and that was, well, people actually started to talk to their Alexa Echo devices or their Google products. So now we were no longer in the middle of the action. We were outside looking in. So we acquired a couple companies to get us into voice processing. And so as you kind of see all the different human interface technologies, during my 8 years there, we did 7 acquisitions, acquiring different type of technology. As I already mentioned, the display technologies, but voice. And so, for example, other products that you may use in your day-to-day life, pretty much every Google Home product, so the hockey puck, smart speakers, use a Synaptics processor to process the voice commands and so on. So now we've moved into, the company's moving into a leadership position with voice as well. And so the real challenge, our mission that we had is kind of up till now, it was up to us to learn how to use our various smart devices. But how do we get the devices to actually learn how to interact with humans? And so to bring up another announcement from Google a couple weeks ago, again, this is a Synaptics part, is they also announced in this little $49.99 device, that'll of course be probably $19.99 on Black Friday, is along with a quad-core processor, there's a teraops of artificial intelligence operations in each one. And so Synaptics built that capability in to start moving the ability to processing voices from the cloud into the edge or right into your home. So really starting to expand the capabilities pretty substantially. And so what is our vision? It's the vision was simply so people stop recognizing there actually is an interface. It just becomes natural. Again, back in 2012, 2013, I would often, as a CEO of Synaptics, be told by people that had smaller children is that their kids only grew up in the touch era. So if they happen to have a TV, young children would expect the TVs to have touch. So they'd go bang on the screen and think the screens were broken. But your children someday they won't understand what a switch is. They'll just expect naturally lights to come on and the temperature to adjust and to recognize who you are and all this. And so again, it becomes so ubiquitous that you don't even know it's there. And so I actually think as exciting as this decade has been in the human-machine interface, I think the next decade is going to be even more exciting because there's going to be true smarts built into these interfaces on the machine side of things to interact with the humans. So that's a good transition now to AMD. So in some ways, Synaptics was kind of almost like your senses, your 5 senses. And that's what we did at Synaptics. The AMD is kind of your brain, where the real horsepower is, the smarts. So So one thing when you come back, so again, I spent a decade at AMD, was gone for 8 years and came back. People remember you, remember what you said. So it's kind of like a mirror is put in front of you about, well, what stuck from the last time I was here about myself. So there's kind of like 5 things that people like to remind me of. Some were kind of on target and some were where it's kind of scary that that's what people remember you for. So one was win ugly. It was a phrase I used to use a lot. So as engineers, you want perfection, no bugs, perfect code, hey, as long as it takes. Well, that doesn't work in the business world. So the business world it's about making money at the end of the day. You serve your shareholders, so you have to maximize shareholder value. And so hey, you have to win. Find a way to win with your product and turn it into a way. It's kind of a sports phrase. It's used quite a bit, but the same thing applies to business. Keep the faith. So AMD is a company that's had up and downs, but I've been using this for now 20. A lot of people put best regards or sincerely at the bottom of their emails. So at least when I sent out emails to large sets of folks, I always had keep the faith is kind of my catchphrase. And people remember that because we go through ups and downs. I think it applies in business as well as personal. You just got to power through. Companies are going to have their struggles. I mean, you can look at an Apple, or all these companies have strong periods and weak periods, and through that, you'll have product cycles where it seems like everything's going wrong. You have to keep the faith. Now, fortunately, this time I've decided to drop it. I mean, this is part about being in management. It's because some people took it as religious connotations, and that was never the intention. And so I would get positive emails about, oh, it's great that your faith is right in front of you, and then I'd get negative, like how are you bringing in religion into a business place? So I've actually set that one aside and said I'll have to come up with another catchphrase. And then the third one was risk Bergman. That one surprised me. I had not actually heard that one, but obviously substituting the C with an S, and because I was noted for taking big risks. But to me, they're never big risks. Every risk, you should just bring it down to an equation and make it quantitative, and then decide to whether you make a risk decision or not. So the example I use internally is, hey, if I flip a coin and tell you it costs you $10 if it's tails, or you get $1,000 if it's heads, we take that bet, and of course they'll all say yes because the odds look pretty good. But now, for those that are going into semiconductors, for example, when you tape out a chip or send it out to production, the mask charges can be $15 million. So if there's a single mistake, it can cost $15 million. But we just have to break that down and say, well, what's the return? What's the likelihood of the mistake occurring? So I've always kind of pushed the edge of risk. This one, again, you'll see this a few more times, is always do the right thing. We'll have a lot of new young engineers, and judgment calls you don't often have to make early in your career, but nevertheless, everybody should have the north compass, so to speak, and always do the right thing. Because you do sometimes get into gray areas, and if you do the right thing in your career, it'll pay off. In my case, I was welcomed back at a company that I had left 8 years ago, because I think at the end of the day, I always do the right thing, and so it just builds out your whole career going forward, because the technology world isn't as big as it feels sometimes. So many of the people that I know you run back into. OTE, this is a great one. Again, I didn't invent these, but I talk about them a lot. So that's opportunity to excel. And the reason I do that, invariably you get objectives or goals for each year. And so at least I tell the people that work for me, if you have like 7 of them, that's kind of the number I like, one of them should be an OTE, which raises the bar. Are you doing something incredible that you get excited about? So at the end of the year, if you pull it off, be super excited about that. And a lot of times, especially in a corporation, that means you have to kind of get out of your comfort zone or your own lane, and you got to expand horizontally. And it's just a great way to stand out in your career. And if when you set your goals, if you don't have one, and you kind of just, okay, check the box stuff, then you're not pushing yourself hard enough. All right, so AMD, I hope most people have heard of AMD. Is that true? Okay, lots, okay, good. Some of the older generation, that's not necessarily, and then I had to do the, well, you know Intel. Well, we compete with Intel and NVIDIA. So we're kicking ass right now. The company's doing fantastic. This has been around 50 years. We are growing very rapidly as a company and projected our growth to go up. I, as the executive vice president, I managed kind of the consumer businesses. So anything that goes into a PC, the graphics cards, the PlayStation and Xbox type of stuff, that's my businesses. AMD, of course, also does server-related products, but I have a peer of mine that manages those businesses. So it's all those different areas, all related to high computing, so high-performance computing. So whether it's the GPUs or CPUs, we believe we got the best in the world right now. And one thing, just to show you how the world is changing a little bit for those that are thinking about semiconductors, like one innovation that we did, there's Moore's law. So, geometry is getting smaller and smaller. Integrate everything. It's kind of the way the semiconductor has been since the first integrated circuit was invented in 1959. It was smaller, faster, more. Actually, our key innovation was going to what's called the chiplet strategy. So you can see this is one of our high-performance desktop processors or our server processors. There's actually 8 little chiplets and then a bigger chiplet. Well, the smaller ones are leading-edge process technology, or in this case, 7-nanometer semiconductor process. The larger one is in a 14-nanometer process because it's less costly. And so the only way we can continue to derive performance at a reasonable cost point is now disaggregate. So we're heading in a different direction. And going forward, so this is it's called 2D or 2.5D because we're expanding this way. We'll go 3D. So now you'll stack the chips on top of each other. And fundamentally, that is the direction we are heading, to continue in Moore's law in a different way. On the performance and cost curve, not so much that we'll be integrating everything into a single device. And so what makes AMD unique is we're really the only company that has high-performance processors and high-performance graphics simultaneously. And that's no mistake why we have won both the next generation PlayStation, I guess it's officially now called the PlayStation 5, as well as the next generation Xbox, because again, we're uniquely situated as the only company with both those capabilities. So I'm jumping through the commercial. So 400 million. So of folks out there use our graphics, so Radeon capabilities, and the best is yet to come. So we have some incredible products in the pipeline. Our most advanced chips now use 40 billion transistors, so which is just an astounding number of transistors, and 2 centimeters or so, even 3 centimeters on a side for a chip. So even just a few years ago, those numbers are beyond imagination, burning several hundred watts each. All right, I've touched on all this. So I'll talk a little bit about our server products. So right now, AMD has 3 or 4% server market share. Intel has all the rest. But as I mentioned, we just came out, the chiplet one that I pointed to has as many as 64 cores or 128 threads in the processor, so just incredible performance. So really, we're 2x the performance per dollar of any Intel solution. And we've set all types of world records. I think as part of that, Oak Ridge, one of the US national labs, has selected AMD for their exascale computer. That will come out in 2022. That'll use tens of thousands of our processors and GPUs hooked together to deliver exascale performance. Okay, so back to the kind of the casual thing. So what have I learned? So be adaptive. I think that's one of the key things. Technology changes rapidly, incredibly fast. So even though I've been in processors and graphics for almost 30 years now, it's amazing how even in that more narrower frame, things have changed so rapidly. Work for companies in growth markets. I've worked in both, and so when you make your career selection, make sure that company is in a growth market. So about 10 years ago, PCs started to flatten out, and that makes life just tough. And I happened to be at that time at Synaptics, where we were in smartphones, and it was great. When the markets are growing 20 to 30% per year, you can make some mistakes, and you just jump to another customer, and off you go. So try to work for companies in growth markets. Build a broad base of skills. Again, kind of getting on the soapbox. One thing that when I came out of university, I was quite the introverted engineer, but I went into sales because I recognized I kind of had to develop a little bit more, and it paid a little bit more than an engineering job too. It was technical sales, but it really stretched me. Suddenly, one day I was in the university studying, not worrying about a lot, and then a couple months later, I'm doing a cold call, trying to sell Texas Instruments digital signal processors or whatever it was to an engineering manager. And it really forced me to develop, as I said, skills that I didn't have and get me out of my comfort zone. After I did that for a few years, I came back to what was called the factory at the time, but the Texas Instruments headquarters, and I did what was called program management. It's usually not considered the most glorious assignment because you kind of basically track action items and track people down and get them to do stuff to execute on a product. But what it forces you to do is learn all the different disciplines. So you have to get with the design engineers, the software engineers, the operations or manufacturing folks. And you just leverage those skills that you develop early in your career, the balance of your career. So networking, again, for engineers, typically it's not comforting, but it's what you have to do if you want to advance. So, and it doesn't seem fair sometimes. It's not like the SAT where kind of everybody takes the test the same way and you all get a score. You can be the world's greatest engineer, but others can move ahead because they've established the networks out there. They've gone out and they've gone to conferences, they meet people, those type of things. Never piss off a former employee or boss. I guess I would expand that because you never know. You might end up back working at that same company again 8 years later. So always leave on good terms. That goes back to doing the right things and all these things. So interestingly, just to give you a little anecdote in that story. So when I switched to AMD, like surprising thing happened to my first boss from way back at Texas Instruments, so 33 years ago. Sent me through LinkedIn, sent me a congratulations note. I didn't even know he was alive, to be honest. I was like, wow, this is cool. And then just on Wednesday, I was at a meeting in Santa Clara, and I'm getting off the elevator, and I'm in a hurry to get to a conference call. And this guy grabs me, shakes my hand, and says, hey, Rick, I used to work for you 30 years ago at Texas Instruments. I'm like, what? And his name was Tom. I can tell you right now, I have no idea who he was. But he apparently remembered me. And I hope to find him again, because he works for AMD apparently now, because he was in the AMD building. But 30 years later, so he's still, I was probably when I was the first manager, so I'm not sure. I want to know what he remembers about me, but evidently he did remember me. So just keep that in mind. Okay, and then one last soapbox here. So I've had groups of Michigan students come a couple times to Synaptics. And then invariably, I've done other of these around the world, meeting with students. And I would say about 75% of the students I meet want to be a CEO. So how many want to be a CEO? You don't have to be shy. All right, you guys are being modest. It's usually in that range. And so normally it's, by the age I'm 26, not, I guess I had to wait till I was, 40 or 45 or something, and go public and be a multi-billionaire. But a lot of people do want to be a public CEO. So what does it take? That wasn't my aspiration. I knew I wanted to be a senior management. So when I kind of hit that level at AMD, I'm done. I'm managing thousands of people. I don't need to be CEO. But then I got a call. So it's a great aspiration. So I already hit that breadth of skills. I mean, by definition, as a CEO, you have to run every function. You have to understand finances. You have to understand operations, and so on. So you have to develop. You don't want to learn those skills on the job as a CEO. So you won't last long if that's the case. It takes tremendous sacrifice. So just to tell you, like my work schedule now, because I'm not always in the Bay Area. I spend a lot of time in Austin, but I leave at 6:15 every morning just to avoid the traffic. For the same reason, I don't bother leaving the office till 7 p.m. So my standard day is 14 hours, roughly speaking, and then I work on the weekends. And when I get home, I do emails at night and do phone calls. So it's again hard work. There's kind of no substitute. Risk taking. I mentioned I left Texas Instruments. I had a great job. I went and joined a startup here in California. I had 3 kids under the age of 5. And at one point I took the plunge. It didn't work out. But again, I learned something. And it was an example, hey, I was prepared to take a risk. But it got me to that VP level, which then propelled me to be in California, where there were a lot more opportunities than there was in Dallas. And it kind of went from there. You have to be optimistic. This is kind of my own thing. You have to be super optimistic. And I get accused of that at times. But you have to balance that optimism with actually, if you have a vision or an idea, you got to get it done too. But the kind of people that are a little half-empty glass people don't usually make it to the CEO level. You have to have a positive disposition. And then lastly, do the right thing. Again, as you move up in management, you can get in the gray area of what is the right thing. And if you just always say, the decision's here, what is the right thing to do? Your conscience usually is telling you. And if you do it, then you stay out of trouble when you have a successful long-term career. And so with that, I've used up all my time. We have a few more minutes for any questions or comments. Yes, sir.
Thank you for the talk. Quite inspiring. So I have a question on your visions or industry visions on the limiting factors of high-performance computing. For example, one is the Moore's law is coming to the end, and the second factor, even we have the 2D and 3D integration, the heat dissipation, the ability to remove heat is still going to limiting the frequency each core can run. And the third, we are hitting the memory war. So the logics are getting faster and faster with the technology scaling, but the speed of memory, the speed of moving data is going to also limiting the highest performance you can go.
Yeah, so no, those are all great questions. So my first statement is I don't believe a broader interpretation of Moore's law is dead. So we will do the 2.5 or 3D space to continue on the same performance projection that we've been on. As a monolithic single die, yes, Moore's law the process nodes are stretching out further and further in time. And the 3 issues that you talked about are absolutely critical. We spend all of our time, we call it PPA, so performance, power, and area, when we make decisions on product. And it's foremost in our mind about some of the things that you mentioned. Now, Moore's law, we're getting around it with the chiplet strategy and going 3D, so we continue to be able to throw transistors at the problem. Frequency is, we're officially maxed at 4.7 today, but we see a path to continue to progress on frequency. And it's funny what you can do within a clock cycle, IPC, instructions per clock. When I was at AMD 8 years ago, there's something called branch prediction. So for those that study microprocessor architecture, you would have asked me 8 years ago, I said, there's nothing left to be done, right? There's no gains left. So I come back to AMD and they're talking about how they squeezed out 20% more for instructions per clock cycle, and one of the key factors of that is our branch prediction algorithm 4.8 is so much better. So these people are continuing to astound with what you can do. In terms of memory, you just can make them bigger, but there's ways to get higher bandwidth memory. It's based on the sophistication of your question. There's HBM, high bandwidth memory devices that stack memory and use wide wide data paths at very high speeds, use low resistive paths to start addressing that particular situation. Power is becoming probably one of the toughest challenges that we are starting to run into, both just the absolute and how do you move it out in these 3D stacks and so on. So no great answers on how we're going to continue to do that other than we're, at least on the high performance area, we're creeping the power budgets higher and higher each generation. What's becoming more important that we do have to deal with is what is your power when things aren't happening. And so, for example, typing on the keyboard, you'll actually shut the processor off between keystrokes, or you're playing back a video. As we move forward, we'll actually shut down the processor between videos, typically 60 frames between each of those frames because we're running so fast, and then turn it right back on again. So the end user has no idea. I mean, that's just an example of what we can, the extent that we're going to manage power.
What do you think like the next step in human interface technology is going to be? Do you think like glasses or even like Elon Musk, like the neural link type?
Yes, so interesting at Synaptics, because we aren't well known kind of in the general public, but within the human interface world, we're quite well known. And we actually had a user experience group for a semiconductor company that's really unusual. It is about a dozen researchers that would look at those type of questions, but pretty much every startup in the world that had ideas around new interface modalities would come through our door and talk to us about that. And the brain waves and so on were one of those. So I think that's probably 20 to 30 years from now, although there's some really cool stuff that I'm sure you've seen from a general media perspective that they're doing, where you're starting to control limbs and so on. So no, in terms, I actually am a proponent on the augmented reality. I really think it's still probably 5 to 10 years away, but in terms of game-changing things, as I said at the beginning of my talk, just doing this it's almost a step backwards from where we should be going. So I think it has to be some type of glass structure that you'll wear. Yes.
I'd like to bring the question a little bit back to the high performance computing. So there seems to be a rising field about in-memory computing, which aims to do downward parallel computing inside a memory which has the problem what they want to break this memory wall. So like then I was wondering what your take is and what the industry's view is about it.
Yeah, it's PIM, processing in memory. So I can't get into it, but we have an active effort in there. But again, it's something we don't see immediate. It's interesting how things come back around. So when we worked with Nintendo in the early 2000 timeframe, they actually did basic graphics processing in memory as well. So for example, you do aliasing, and you're looking at near pixels in simple blending operations you could do right in the memory. And of course, that opens up massive bandwidth, which in graphics, memory bandwidth generally equals performance. So I think it's an open topic, but it's not something you'll see in the next several years. There's some startups, of course, in AI that are really starting to push that direction. But it does, from a manufacturing perspective, building memory devices, even though we might talk 7 nanometer, building a memory device, building a processor are totally opposite. Different process technologies, different directions. One's obviously highly structured, lower power. The other is very high frequency and very power oriented. Yes?
Do you have a defining moment in your career where you kind of realized you became an engineer to a great leader?
Well, those are two things. From when I changed from an engineer. So in some ways, I was never a hardcore engineer when I joined Texas Instruments, because I went right into sales. You would do an 18-month rotation, so I did software programming. But when did I go to the dark side, for sure? It was probably when I accepted to a marketing role. Because even though marketing in a technology company, you have to absolutely be a good engineer. at that point, my engineering skills clearly started to diminish. And then when you became a leader, yeah, that's a great question, but there was no like, oh wow, I'm the anointed one. I think it was, I never really worried about it. I'd say that was the best advice I can give you. I always, what's best for the company. I guess there was kind of a moment. I remember it was the first time I was with AMD. The CEO came to me and said, "Hey, you can take on, to keep the story short, you can pick up this other organization." And you know, the ambitious part of me said, yes, I can double my headcount, double my responsibilities. But it didn't make sense. And so I told him, no, it doesn't really make sense for these reasons. But then 6 months later, he came to me with a proposal that quadrupled the size of the organization, which made a lot more sense because I demonstrated that I was more interested in the company's success rather than my personal success. And to me, that was probably kind of the defining moment that got me to a very senior role. Yes, sir.
So, your thoughts on quantum computing?
Oh, man. I was wondering, is somebody going to ask me about quantum? I have no idea what quantum computing is. I've tried reading articles on it and qubits, and we even do something like they freeze one of our processors, you know, on the front end of the quantum computer. And then I read, I hope I have smart enough architects that can actually tell me when it's coming. And they tell me not to worry about it. It's still 5 to 10 years away. But yes, I've read the Google articles about it. Yeah. So, but somebody else can fill it in. But I can't answer that question intelligently, I'll have to admit. Yes?
What are your conference calls like? Do you enjoy them? How much of the day does it take up?
Oh, you mean just as meetings and so on? I would, so in terms of conference calls or meetings, I at least 9, I mean, I almost don't do anything during the day except for meetings, and I don't like sit in front of a computer, and I'm either meeting or on the phone. Or traveling. There's no, later I do emails after hours and that type of thing, but that's the nature of senior management.
So obviously when you were here, it was very different, but I'm curious when you look back over your time, like what kind of advice would you give to students in terms of how they can most enjoy their time here or most take advantage of it?
Well, I kind of had that first slide, and that was kind of the summary, not so much the enjoyment part. So I managed to balance things, I guess is the best way to say it. No, and make friends, and don't forget these friends. I mean, it's they should come up through the rest of your life and your career. You'll leverage those connections. And Michigan means something, so it's kind of cool. Invariably, you run into other people from Michigan in the technology industry, and it certainly helps that there's many successful Michigan engineers and management out there to get to know.
Are there other Michigan people at AMD right now? Do you guys have lunch together?
No, it's not at, there certainly was at Synaptics, so I haven't been able to fully infect AMD again, so we'll see what we can do. Now there's not, fortunately there's nobody from Ohio State either, or they haven't come up to me and laughed at me in a while, but no, it's like at Synaptics, our general counsel was from Michigan, and our head of IR was from Michigan. Way in the back.
On site, and then you just have the connections, for example, if you're just carrying your phones with lost so since AMD is kind of a leader, especially in this market, is this something that you push, or do you think that's not?
That's a fantastic question, because we talk about that all the time. Because yes, we are in the PlayStations and in the PCs, and we're also in the cloud. So specifically, cloud gaming is a really big question, and with 5G coming, can you make the experience running it all in the cloud equivalent to what you can locally, and is an opportunity or threat for us? So we're, for example, Stadia, the Google Stadia solution uses AMD GPUs in the cloud, and so we're playing on both sides of the fence. Generally, I believe it's an opportunity for us, because the more gamers we create, we will find a way to win. and for people that enjoy that very high fidelity experience. And so we're doing investments in both areas. I think ultimately for call it really high performance gaming, the latency just is not going to get there wirelessly or wired. You will want local compute resources, and maybe it becomes a cooperative type of model. There's some like you do the shading type of activities in the cloud, and then push those down. Obviously, when you're in the cloud, you can do massively parallel type of games that you just can't do locally. So there's also some positives. So it's a great discussion topic, because everybody's getting more and more used to being in the cloud, so to speak. Yes.
How do you think of
So they're a good second place company. Yeah, so they obviously they just announced their results yesterday, so they're on track to do $71 billion this year. AMD will do about $7 billion, so they're 10 times our size. So they make a nice target for us to go after. But they've done some great things. I mean, there's no doubt they've pushed. I mean, the best thing for AMD is our process technology used to lag Intel's by 3 or 4 years. And so if you're in the high performance computing area, that's a tough anchor to have. Now it's working with our partner TSMC. You could argue TSMC is about a year ahead of Intel on process. And I think our results are starting to show that inherent advantage they have is gone. So they're going to have to fight us on a more level playing field. So we look forward to it. They actually have a bunch of AMD alumni there, actually, on the graphics side, because they didn't have that capability. So they're trying to build up the graphics to compete with us. All right, I think we are probably out of time. But those are great questions. Thank you very much.